Hello, welcome back with trigonometry function. So in this section we continue with trig function. We will be talking about tangent, cotangent, secant and cosecant. We will be discussing the domain and range as well as the graph of each function. Okay, so let's get started. Section 3.6. I'm going to put over here tangent, cotangent, okay, secant and cosecant function. Okay. Okay. So on the first part, let's talk about tangent function. Last time we already talked about sine, cosine, right? We discussed the domain and range of those functions. We did some graph. Okay, and we also last time we just did we did transformation for cosine and sine function. So now on the first part of our lecture today, let's talk about tangent function. First Roman tangent. Alright. Okay, so the parents function of tangent function will be f of x equal to okay, first part, parents function. F of x. So this one will be f of x equal to, you know what, I'm going to use different color. F of x equal to tangent of x. Okay, again the x over here will be in degree, or it will be in radian. Okay, so the period over here, the period, we already talked about a period. So the period is nothing but the distance, right? Travel for one revolution. So the period over here is where it will be pi instead of 2 pi. We for one revolution only pi. The domain will be all real number except for pi over 2 plus k pi. So what I mean over here that, so if k equal for k from 0 to n, right? So if k equals 0, so at pi over 2, they're gonna be the vertical asymptote right over there. So for the tangent function, there will be a lot of vertical asymptote because there's a bunch of value where the function tangent cannot be defined, because if you notice, tangent will be sine with cosine, and you see that the cosine, whatever the value, to make the cosine equal 0, that could be make the function undefined. So that is right over there. Okay. So the period is pi, only pi. Okay. How about the range? The range will go from negative infinity to positive infinity. Okay. In this case, the amplitude in this case, the value in front of this value over here will be 1. So amplitude is 1. Okay. And another thing is, I want you to notice for the tangent function is that tangent function will be the odd function. Oh, I believe this is also, let me check what was it could be. Yes, it will be odd function because odd function because tangent of negative x equal to negative tangent of x. So the odd function, so that's why it's going to be a symmetric about the origin. So this is symmetric about the origin. Okay. Alright, let me give you the graph of the tangent function. Okay, so this is what it look like. Okay, so the period will be only pi. So just think about if k equal to 0, right? So we have pi over 2, right? And we also have negative pi over 2 would be the vertical asymptote. So so from negative pi over 2 to pi over 2, so the period will be pi, totally will be pi. So the vertical asymptote, I'm gonna do it. Okay, so I'm gonna have it over here and over here, right? So it'll be this will be pi over 2 here, and this is negative pi over 2. That make the whole revolution will be inside here. Okay. All right. So if you go ahead and graph it using the table, as we already did last time. So we're gonna have x over here, and tangent of x over here. So if you have 0, so tangent of 0 is 0. How about tangent of pi over 2? Pi over 4. Tangent of pi over 4 give you 1, right? And tangent of negative pi over 4. Tangent of negative pi over 4 would be negative 1, right? So pi over 4 will be around right here. So I'm gonna make it the amplitude is 1, so it will be right over here. 1 right here. Okay. It's negative pi over 4 right here, and negative 1 right over here. So the graph of tangent function will be something like this. It's very interesting curve. So it's gonna go through this, and it's gonna go through. Oops. So it's kind of like that. I know it's kind of hard to grab, so I think I'm gonna make it one smaller so that it's easier for me to grab. So let make it 1 over here. There you go. Oops! Oh my God! I deleted. There you go. Alright, make it a negative 1 over here. Okay, so we have 1 will be here, and will be here. Okay, so the curve will be something like this, going up like that, and it's gonna be like that, and it's going to do this, and it's gonna get really close to the asymptote. So this is one revolution. So if you continue, we have a bunch of vertical asymptotes. So we have another revolution like this, another one revolution, another revolution like that. So that's why the domain will be go everything from negative infinity to positive infinity, except for all the vertical asymptote position right there. Okay. Now, what if we want to apply the transformation into that? Okay. So this is a transformation form. Okay. So if we have a transformation form, we can have function like this: f of x equal to a tangent of bx plus c plus k. Okay, so we already talked about it. So all the function kind of the same, right? We have a, b, c, and we have k represent the verticals shifting. This is The amplitude is tell you this is slanted. It's not slanted. It's elongated along the y-axis. It's vertical compression and vertical stretching and compression. Okay, so the period will be of course will be different. The period will be pi over b, and the phase shift we can calculate easily by we set up the argument equal to 0. So the phase shift will be to tell you how many units go into the right and how many units go into the left. Okay. Alright. Now let me give you this example. In this example, I want you to sketch y equal to -3 tangent 1/2x. Okay. Alright, let's see. Okay, so first of all, we need to calculate the period. So period will be pi over b, will be pi over 1/2. So the period will be 2 pi. No vertical shifting. We have the amplitude will be 3. But I mean, amplitude will be 3. We can mark 3 everywhere we want as long as it's on the y-axis. So we're gonna do the Paris function first. Okay. Okay. So the period will be 2 pi. So 2 pi here. Oh, the period will be 2 pi, so it will be pi here and pi here. Negative pi here. So the vertical asymptote will be right here. So I'm gonna just go ahead and sketch one revolution for you. Okay, so it depends on the question. What if the question asks you to sketch 2 revolution, or maybe to go from one point to another point? So depend on the question. Okay. So I'm gonna grab this assist. Let's put 3 to 1 2. Let's put 3 is over here. So -3 here and 3 here. So we're gonna have pi over 2 right over here. Okay. So x equal pi over 2, right? Pi over 2 will be pi over 4. Times pi over 1 will be -1 and 1. So we're gonna have the value will be right here. And over here the value will be right here. Alright, so I'm gonna make a curve. So make a curve will be going like that. So we're gonna make it go through the origin. And it's gonna make up like this. Okay. Okay. Alright. So I'm gonna have a curve like that. Okay. However, but we need the negative. So negative, we need to have a reflection about the x-axis. So reflection about the x-axis is going to be something like this. So we're going to have the red one. So reflection about, so we're going to make it the other way around. So we're going to have something like this. Oops. It's kind of very hard to draw, you know. Make it curve. You know what? So I'm gonna make reflection. Okay. There you go. Something like that. Just a reflection. Sorry, it's very hard for me to draw over here. Okay. Okay. So this is the function y equal to -3 tangent 1/2x. And the y one is just y equal 3 tangent of 1 over 2. So that's a big difference right there. So there's only one transformation for this case. Alright. Now, let's do another one, huh? Example 2. Example 2, we're going to have this tangent pi. So look like amplitude will be 1 right there. See that? Alright, we have phase shift, we don't have vertical shifting. So the period is to pi over b, so pi over 2 will be 2. Okay. And over here, I just want you to sketch it from negative 1.5 and 2.5 only. Okay. And the phase shift, well, we can calculate the phase shift will be pi over 2x minus pi over 4 equal to 0. So pi over 2x equal pi over 4. So x is half. It looks like it's going to move into the right half of the unit. Okay. Again, we just go ahead and sketch do the parents based on the parents function first. Okay. Then we're gonna move left to right, depends on the phase shift. So with y here, x here. So the period is just 2, so there'll be 1 here. Just mark at 1. And over here gonna be negative 1. So we're gonna have vertical asymptote right over here. Okay. Okay, so we just draw one revolution first based on the parents function. So we're gonna have 1 1. So we're gonna have something just 1 x equal. So if it's 1, it's gonna be around right over here. Right over here. Okay, so we're gonna have tangent go like that. Alright. Good. Okay. Okay. And now we're gonna shift it to the right half of the unit. So this is a half right here. So everything moved to the right half of the unit. Let me see. I think I calculate this minus. Oh, this plus. So this, I'm sorry, this is plus. So look like we're gonna move it to the. We'll move to the left, not to the right. Okay. So let me use a different color here. So we're gonna move it to the right half of the unit. So from here we're gonna have here. The vertical asymptote will be here. And this is new vertical asymptote here. Okay, so it's gonna be something like this. So to a unit is gonna be something around like that. Okay. So it's gonna be. It's kind of very hard to grab, guys. Alright. To the right half the unit. Okay. So move to the right half the unit. So the value over here will be what? Will be this negative 1. So it will be it's a negative 3 over 2, right? Negative 1.5 right here. Okay. But we want to sketch from negative 1.5 to 2.5. So this is 1. So this is 1 right there. 2 will be right over here. 2 will be here, and we have another easily to see. So here to here, here. So the new vertical asymptote will be, this is 1, 2. We're gonna go from negative 1.5 to 2.5. So this is 3 right over here. So 2.5 up here. So we need another one up to this point right here. Alright, so this is new vertical asymptote, and 2. So we have another vertical asymptote at 2.5. Okay. So the center will be right over here. Okay, so we have another one. Okay. There you go. Alright. So the new function, so the one with y will be y equal tangent pi over 2 x only. But when we do the yellow, it is y equal tangent pi over 2 x plus pi over 4. Okay, and now if you have the yellow and the purple, which is give you the graph on the restriction they want you to sketch, which is go from negative 1.5 to 2.5 over there. Okay. Good. Alright. So I want you to go ahead and practice in the third example, in example number 3 and example number 4. I want you to go ahead and do this yourself. Okay. Tangent of 2x minus pi over 2 minus 1. And example number 4, I give you y equal negative tangent of 2x plus pi over 2 plus 1. Okay, so you're gonna do the same way. Okay. Alright, you're gonna calculate the phase shift, calculate because I didn't put the restriction, so the difference between here and here is that I didn't put any restriction. So for example 3 and example, you just need to do one revolution. One revolution if I do based on the parents function, you do one revolution. Oh, maybe you gotta move up. You know, I think I'm gonna go ahead and do this one for you. Then you're gonna do example 4 by yourself. Okay, let's do this for you. So look like we have the reflection about x-axis. So we have period will be pi over b. So the period is just pi over 2. The phase shift is 2x minus pi over 2 equal to 0. So 2x equal to pi over 2. X equal pi over 4. So they shift the pi over 4 unit. Okay. So I don't have enough space. So you know what? Is there a way I can move this up here? Example number 4. I'm gonna go ahead and sketch over here, okay? Because I don't have enough space. So I'm gonna sketch here. Alright, so period just pi over 2, so pi over 2 here. So this pi over 2, so this way could be pi over 4. And over here will be negative pi over 4. Pi over 4, pi over 4. We pi 2 pi over e, 2 pi over 4, which is pi over 2. So the parents function will be something like this. Okay. So we're gonna have something like that. Half of this, we have 1 and -1 here. So we're gonna go and do like this. Alright. Now we're gonna move down. Oh, let's do a shifting to the right first. Power 4. Shift everything to the right, power 4. So let me use different color here. To the right, power 4. So everything moved to the right. Power 4. Oh wow, this one will be power 8 right here. Wow. So you move everything to the right, power 4. I mean, that's a lot. You move this one over here. So the new one. So you double that will be just power 2 right over here. Right. This one will be here. So the whole thing is gonna be something like that. So you're gonna have something like this. Okay, so we move it power move all the way to the right, power 4 unit, which is give you power 2 as the vertical asymptote. Okay, now we're gonna do reflection. So this is no reflection yet, so this is just y equal to tangent of 2x minus power 2, and the equation here will be y equal to tangent of 2x only. Now we're gonna do reflection. So reflection is gonna be something like that. Reflection of the green one. Okay, so we're gonna have something like this. Okay. Reflection. Okay, so this is just y equal to negative tangent 2x minus power 2. Alright, so after the reflection, we gotta do shifting down 1 unit. So everything go down 1 unit, so it's gonna go down here. Okay, so it's gonna become this. Let's go down here. Okay, there you go. It's kind of very hard for me to grab. Oh my god. Alright. Hopefully you guys can see it, because this is one right here. So new one right here. So the pink one will be the function y equal negative tangent 2x minus power 2 minus 1. Okay. And now example number 4, go ahead and do it for yourself. Okay. Okay, so the second function is cotangent function. Sorry, I need to fix this. Okay. And everybody know that cotangent is based on the cotangent is 1 over tangent, right? So that's why the cotangent graph kind of similar to a tangent function. However, let's see if the domain and the range will be the same or not. Okay. So on the second part, let's talk about cotangent. Okay, again, let's talk about parent one first. Okay. So the parents one will be f of x equal to cotangent of x. Okay. And similarity between cotangent and tangent is the period. Period is still pi. Okay. Amplitude, of course, amplitude in this case will be 1. Range will be the same. Range go from negative infinity to positive infinity. But domain is different. So domain will be a real number except for k pi only. So they can have vertical asymptote at pi, at 2 pi, and so on. So that's why the sketch is kind of is also different. I mean, the shape is kind of same, but it's quite different. And cotangent is not symmetric about the origin. So it's not odd function. Okay, it's not odd function. You will see if I go ahead and grab it, you see that it's not symmetric about it. It's not symmetric about the origin at all, because it's kind of shifted to the right a little bit compared to the tangent, and here I'm going to show you. So a period will be pi. So and we have one revolution will be pi. So we have a vertical asymptote at pi, and we also have a vertical asymptote right over here. The pi. Okay. But because the period is only from only pi, so everything will be between here to here only. So we're gonna have pi over 2 over here, and cotangent of pi over 2 will be what? Will be cotangent of pi over 2. It's undefined. Tangent. Let me see. Tangent is side. Cotangent. Is over here. Will be cotangent. Could be. I think a little bit here. Okay. Cotangent of pi over 2 equals 0. So you see that it's going to go through here. At cotangent of pi over 4 is still 1. So it's here. So 1 here. Okay. And cotangent of pi over 2 plus pi over 4, which is 3 pi over 4. Okay, so 3 pi over 4 will be pi minus pi over 4, right? So think about tangent of 3 pi over 4 will be tangent of pi minus pi over 4, right? Tangent of pi minus pi over 4, which is in the second quadrant, so tangent will be -1, right? So it's going to have something like this. So if you go ahead and sketch it, you will see that you're going to have the graph something like that, going through the origin, going through here, and make a curve down here. So this is one revolution line. And tangent of cotangent of 0 is undefined, alright? Cotangent of 0 undefined. So that's why we have vertical asymptote right here. Okay, because cotangent is cosine over sine, sine of so this is sine of 0, 0. So you see that at the bottom, so it's undefined at 0. Okay, so this is one revolution for cotangent. Of course, if you do another revolution, you're gonna have many revolution here, right? But I'm just going ahead and do one revolution for you. Okay, one revolution only. So that is the parents one. Now, how about if we go ahead and apply transformation? It's kind of the same thing, you know. everything the same. We apply transformation, we're gonna have what? We're gonna have y equal to a cotangent bx plus c plus k. Okay, so the phase shift over here will be what? The period will be what? The period will be pi over b, right? Phase shift is bx plus c equal to 0. So x equal to negative c over b. There you go, that's the phase shift. So I want you to go ahead and do this yourself. I'm not doing this anymore because this is kind of similar to tangent. Okay. 3 pi over 2. And example 2 is y equal cotangent 3x plus pi over 4. Okay, if you have trouble with sketching of this, let me know. Okay, so I'm not gonna go spend too much time on cotangent because it's similar to tangent. Now, on the third part of our lecture, I'm going to talk about cosecant. Okay, cosecant function. And we know that cosecant is 1 over sine, so of course the graph of cosecant function will be based on the graph of the sine function. Okay, we're going to have the parent one, parent function of cosecant function. We're going to have something like this. So we're going to have y equal to cosecant of x. And as we know that the cosecant is 1 over sine, right? 1 over sine. So that's why the domain is not going from negative infinity to positive infinity anymore, because over here is undefined at sine equal to 0. Sine some value over here, the max sine equals 0. So that's why 1 divided by 0 undefined. So there's a bunch of angle that makes sine equals 0. So that is undefined right there. It means that we can have vertical asymptote right over there. Okay, and that's why the domain will be different. How about the range? The range is also different. It's very interesting range. So over here we know that sine will be different from 0. And because cosecant is based on sine, so the period is still 2 pi. Okay, the period is still 2 pi. And we know the sine is odd function, so cosecant is also the odd function. So cosecant is odd function. So cosecant of negative x equal to negative cosecant of x. Okay, so this odd function. Okay, so odd function. And the domain will be all real number except for k pi, because this is the value make the sine equals 0 is undefined right there. So sine of pi, remember sine of pi what? Sine of pi is 0, right? The sine of pi is 0, sine of 2 pi, 3 pi, you know, blah blah blah. So 0 is undefined, so the vertical asymptote will be over there. In the range will be different also. The range will be go from negative infinity to negative 1, union negative 1 to positive infinity. So it means that they're gonna start for the range. They always start from 1 up, and negative infinity to negative 1, and from 1 up, I'm sorry, so it's positive 1 right here. Okay, alright, so I'm gonna go ahead and do a quick sketch for you with this. You will see. Okay, so I'm gonna, because the period is 2 pi, I'm gonna go for 2 pi. So let's say 2 pi over here. So this is pi, and this is pi over 2. because it's based on a sine function. We know the sine function will go like this. So this is one right here. It's -1. We know the sine function will be something like this, right? This is the sine function for one period. Okay. All right, and vertical asymptote will be right over here. Okay, vertical asymptote will be here. Okay, and now this is the cosecant. It's very interesting. Everybody, look at this. So cosecant is gonna start over here. So it's gonna make a curve like this. There you go. Ooh, it's interesting, right? Interesting. So we're gonna have a curve like that, and you can have a curve like this. There you go. So look at that. If you go ahead and do more, so we have one over here. We have one over here. So this is still symmetric about the origin. It's still symmetric about the origin. So that's why it's still odd function. Okay. So this is just one revolution. Okay, for cosecant. Okay. Now for the transformation. So we're gonna have this f of x equal to a cosecant of ax, or bx, I'm sorry, bx plus c plus k. Okay. Okay, we already know ABC means, so it's kind of same as any other function. So I'm going to just go ahead and go straight to the example. I want to sketch this 2 cosecants of pi over 2x minus pi. Okay. So period will be the 2 pi over b. So b period will be 4. Phase shift the pi over 2x minus pi equal to 0. So pi over 2x equal pi. So x equal 2. So everything move to the right 2 unit. So we're gonna have something like this. I can't believe it. I cannot draw even straight line here. Okay. So period with 4. So let's make it 4 right over here. So it'll be 2 right here. Right. So let's do one revolution first. So the amplitude will be 2. I'm gonna put over here 2. Over here is -2. Okay. Alright. So we know that the sine will be like that, right? So that is the sine. Okay, so the asymptote will be here. Okay, so right now we're gonna have a curve like this. Okay. Alright, so that is one revolution, and this is no shifting. Yeah, so this is just y equal to 2 cosecant of pi over 2x. Okay. Alright, now we're gonna move it to the right 2 unit. So everything move it to the right 2 unit. So what we're gonna have? Move it to the right. Move it to the right 2 unit. So we're gonna have 2, 4. 6 over here, right? Okay, because over here they don't put any restriction, and they don't tell you like how far we're gonna go ahead and sketch it. So I just sketch one revolution only. Okay. So this is, we're gonna have something like this, right? This is for sine. Okay, so move everything to the right 2 units. So we're gonna have something like this, right? Alright, move it to the right 2 unit, and move it to the right 2 unit. There you go. So that is one revolution. So this is going to be y equal to 2 cosecant power 2x minus pi. Okay. Alright. Now in the second example, I want you to go ahead and do it yourself. Okay. Very easy. Very easy. Y equal to 3 over 2 cosecant x minus pi over 2. Okay. Now just think about it. What if they over here they add 4? So I mean you just move up 4 unit. You know what I mean? If you add 4, then you just need to move up to for the add 1, right? Add 1, you're gonna move, or add 2. If it add 2, then you move up 2 unit over here. So this is 4 right over here, right? If it add 2, you're gonna have right over here, and this is what you're gonna have over here, right? Right. So if it's like that, you're gonna have function like this. You're gonna have if it is like that, you're gonna have something like this. Right, and this one you're gonna have something like this. Okay, that will be y equal to 2 cosecant pi over 2 x minus pi plus 2. See, simple. Very easy. Okay. All right, now last function. Last function is secant one, number 4. And secant is based on the cosine. Secant function. Okay. So again, we're gonna have the first one will be the first one. So we're gonna have x equal to secant x, which is 1 over cosine of x. So any value that make cosine equal to 0 over here will be undefined. So that will be tell you the domain. Okay. Okay. So the period, again, the period is still 2 pi. Domain will be real number, except for pi over 2 plus k pi. There you go. And the range, again, the range will go from negative infinity to negative 1. Oh, I think I have something wrong. From 1 to positive infinity. I think I have something mistake right over here. It should be this. This should be a bracket. Yeah, because it's still defined over there. Okay. Okay. All right. Now go ahead and sketch it. So we're gonna have something like this. Okay. And this one is cosecant is even function. Okay. This cosecant is secant is even function. Because secant is 1 over cosine. So you will see that it's going to respect it's going to be symmetric about the y. Last time it's symmetric about the origin. This is cosecant. It's cosecant. It's odd function, so it's still symmetric about the origin. Okay, but this now is symmetric about the y. You will see. You can have something like this. So 2 pi will be here. So we're gonna have so this is 2 pi will be pi. So pi over 2. So it look like this is the asymptote right over here and right over here. Right here and here. Okay. And if you go ahead and draw the cosecant, I don't know if you guys still remember how to draw the cosecant. So this is one right here. So this is -1. So cosecant go like that, right? There you go. There you go. That's how cosecant go. Okay. And now for I'm sorry, that's as cosine goes. That's how cosine goes. And now we're gonna do the secant. Secant, we're gonna have something like this. It's gonna be something like this. Okay. Alright. And we're gonna have on this side. There you go. And here you go. If you go ahead and flip it to the other side, right? So you will see. So over here you're gonna have another one right over here, right? And we're gonna have all the way down like this. So we're gonna have one right here. It's gonna be negative pi here. Right. So we're gonna have something like that, right? So there's another piece right over here, right? You see that? Okay, so then another piece right over here. So that's why I said it's still symmetric about a y. So this is even function. So secant of x is even function because it's symmetric about a y, y axis. Okay. Okay, so that's what it is. And now for the parents one. The transformation, sorry. It's kind of the same thing. Everything is the same. So you have f of x equal to a cosecant. A secant, I'm sorry. Secant bx plus c plus k. Alright. And the phase at the period will be 2 pi over b. And phases will be the same thing. Okay. So again, I'm gonna give you this example, and I want you to go ahead and do it yourself. Okay. Very easy. All the sketch is kind of the same thing. The method, I mean, what you do is kind of the same. But now for this one, I'm gonna put the restriction. It means I want you to go from 1 to 1 only. Okay. Alright, so I think that's all for algebraic function. If you have any question, please let me know. Okay, so go ahead and practice on yourself on example I did not cover. If you have any concern, send me a message. Alright, I'll be seeing you next time. Bye bye.